Good morning, students. Hope you guys are all doing well today. As discussed, you have a substitute today, but we will be doing an introductory lesson into our next unit, which is trigonometry. So hopefully you should have this paper in front of you and something to write with. The concepts that we're going to discuss today are review, so that when we do the trigonometry sections next week that you're prepared and have a little bit of a memory of what you did in geometry. So here we go. For our trigonometry chapter, we have to combine special right triangles with trigonometry. Understanding this section is going to make T1 and T2 a whole lot easier. Okay, let's take a look back at what SOHCAHTOA stands for. So SOHCAHTOA is a memory device that helps you to remember the sine, cosine, and tangent ratios. So the function is called sine, and it's abbreviated SIN. The sine of some angle is equal to the opposite leg, we're just going to write opposite, divided by the hypotenuse. This symbol right here is theta. It's a Greek symbol, often used for angle. Just the sine of some angle is equal to the opposite divided by the hypotenuse. So that's the sine, opposite, hypotenuse. Now the is for cosine. So the cosine of some angle is equal to the adjacent divided by the hypotenuse. Now it may help to review a little bit how I find these adjacent and opposite sides. So if we just add a little triangle here, it has to be a right triangle. All trigonometry, for our sake at this point, has been done with right triangles only. So I have some angle theta. And if this is kind of my reference point. So if I'm looking for the sine, okay, I'm looking for the opposite leg, I go opposite the circle way over here, and this would be opposite. Opposite the triangle. The hypotenuse is always, always, always the side across from the right angle. So this is the hypotenuse. And the A stands for adjacent, so this one would be the adjacent to the angle. Now these will change if you change angles. Okay, back to our functions. The tangent of theta is equal to the opposite divided by the adjacent, TOA. So sine equals opposite divided by hypotenuse, cosine equals adjacent divided by hypotenuse, and tangent equals opposite divided by adjacent. Okay, when finding trigonometric ratios, we always use an acute angle as our reference angle. So when we're finding the sine, cosine, or tangent of an angle, it's always one of the acute angles in the right triangle, never the 90-degree angle. That's my point of reference. Example 1. Set up the sine, cosine, and tangent ratios for the acute angle labeled with a capital letter. So in this case, angle A. And what I did was when I created the notes in the worksheet, I tried to pair them up. So the questions on the assignment that correspond to, that are similar to this example, are 1 through 3. So that's where to look. Okay, so the sine of A. So sine is opposite over hypotenuse. So I'm here, this is my point of reference. So I'm looking for the opposite leg, which is 6, divided by the hypotenuse, which is 10. Now I can't leave it like that, I have to simplify. So if I divide by 2, I would get 3 and 5. And I'm just going to rewrite my answer. The sine of angle A is equal to 3 divided by 5. And there we go, we've got the sine. Okay, so for the cosine, similar thing. The cosine, so ca is the adjacent divided by the hypotenuse. So the cosine, this is just how I'm setting it up. The cosine of A is equal to the adjacent leg. Now it's the adjacent leg. This can't be the adjacent because it's already the hypotenuse. So the adjacent divided by the hypotenuse. And again, must always reduce. Now you will see something a little bit different in this unit. Oh goodness, you couldn't even see that. It wasn't up far enough. Sorry about that. You will see something a little different in this that you didn't see last year, where you have negative numbers. And that's because we're going to orient it on a coordinate plane eventually. I'm so sorry you couldn't see what I was explaining with cosine, but I'm not going to start over. Okay, tangent. Tangent ratio is equal to the opposite divided by the adjacent. So the opposite leg is going to be 6 and the adjacent is negative 8. And I reduce and I get the tangent is equal to negative 3/4. So I've set up my sine, cosine, and tangent ratio. If you feel like you need a little more explanation, you could pause the video at this point and help each other with any questions that you have. Okay, example 2 is very similar. The only difference is I've actually given you a measurement for the angle. I don't know what this letter C is right here. You can just cross that out. Set up the sine, cosine, and tangent ratios for the reference angle labeled. So again, this is similar to questions 4, 5, and 6, 7, and 8 in your packet. And now we're going to throw in some numbers that are maybe, not quite as pretty, some radicals, positives, negatives, different things like that. So here we go with the sine of 60. So sine is equal to the opposite divided by the hypotenuse. So from 60 degrees, I do the opposite side divided by the hypotenuse. I can simplify, which would give me the square root of 3 divided by 2. Okay, the cosine of the angle, so the cosine is equal to the adjacent divided by the hypotenuse. So my adjacent leg is 5, hypotenuse is 10. This gives me a real simple 1/2. And then the tangent of 60. So the tangent is the, the tangent is the opposite divided by the adjacent. So opposite is 5 radical 3 divided by 5. The 5's can simplify, and I get the tangent of 60 degrees is equal to the square root of 3. So I don't know if this triangle rings a bell. This is actually a 30, 60, 90 triangle, which is going to bring us into the next part of our notes for special right triangles. Okay, so if you flip it over, make sure this is in the screen this time. We also need to know all about special right triangles. And I don't know how your geometry teacher taught you last year, but what it is that there are two different kinds of triangles that we consider special right triangles, 30, 60, 90, and 45, 45, 90. And you can see them in front of you here. And the special thing about them is that the ratio of the sides is always the same. So the sides are always in the same exact proportion. So here, for a 30, 60, 90 triangle, the sides are always in ratio 1, square root of 3, and 2. This is one of those things that you're just going to have to memorize. I know that the 1 goes across from the 30 because it's the smallest angle, it's the smallest length. 2 goes across from the 90 because it's the biggest angle and it's the biggest length. And square root of 3 is actually 1.7 something, so that goes across from the middle. So what I'm going to do is when I'm using my special right triangle, I'm going to set this up. Across from the 30 degrees goes a 1. Across from the 60 goes a radical 3. And across from the 90 goes a 2. I'm going to put these numbers in circles because they're not actually the length of the sides, just the ratio. It could be 2 times that or 4 times that or 15 times that. And then I would set up the 45, 45, 90 the same way. This is all tools that you're going to need when we start the trig sections. Okay, so again, I kind of lined them up here so that you can see that they go together. For a 45, 45, 90 triangle, the sides are in ratio 1, 1, radical 2. Since the 45 degrees are the same, that means the sides across from them are the same. So across from 45 goes a 1, across from 45 goes a 1, across from the 90 degree angle, also known as the hypotenuse, goes the square root of 2. Okay, next concept. In this chapter, we will be learning about what's called the unit circle. And a unit circle is a circle on a coordinate plane with its center at the origin right here. The radius is 1 unit long. That's why it's called the unit circle. Okay, and it looks like this. What we're going to be doing is we're going to be creating right triangles in here and then finding the sine, cosine, and tangent of them. So for example, to get you started, this is going to be my radius. If I take this and I'm going to draw this in another color. You can see it better. And what's going to end up happening is I'm going to end up drawing right triangles from this to the x-axis. So I would take this point right here and draw it straight down and then finish off the triangle. For every single spot on this circle, I can draw a similar right triangle, okay, where the hypotenuse will always be 1. This is always going to be 1 because it's a unit circle. The lengths of these x and y values are going to change, but this will always be 1. And just like a coordinate plane, this is some point x comma y. I go over x, up y. Okay. Our last example, similar to questions 9 through 12 on your worksheet, and I know that this is all, you know, bringing it back from last year and a little bit out of the past, and it's going to take some review. That's why I'm giving you this opportunity. Make sure you help each other, help explain it. Look things up if you need to. Okay, example 3 asks us to set up just the sine and cosine ratios for the given reference angle that's labeled. So I have labeled here the 30 degree angle. We're talking about the acute angle. And I'm going to set up my sine and cosine. This time I've got some fractions, so it's going to be a little bit different. Okay. Sine. So I'm going to set up my sine ratio. Now I'm here at 30 degrees, so I'm going to be going opposite, adjacent, and hypotenuse. The sine is equal to the opposite leg divided by the hypotenuse. So Starting here, I have the opposite leg, that's a negative 1/2, divided by the hypotenuse, which is 1. And what you'll notice is that since the hypotenuse is 1, it actually has no meaning, really. It just gives me negative 1/2 for the sine of 30. And when I do the cosine of 30, the same thing is going to happen. So the adjacent leg is negative square root of 3 divided by 2, all divided by the hypotenuse, which gives me the cosine of 30 degrees is equal to negative square root of 3 divided by 2. This works out like this because it's a triangle on the unit circle, and hence the hypotenuse is 1. Okay, that's all the notes that I have for you. So make sure when you're doing the worksheet that you're looking at the problems that are similar on your notes and help each other out. Thanks, guys. I hope you have a great weekend, and I look forward to seeing you next week. All right, bye.